Okay, so hi everyone. I wanted to have an Upsolve session for a while now. So I actually created a mashup for myself, and it contains like some problems from 2,000 rated to 3,000 rated problems that I either had like no time at all to solve during the contest, or I just missed for whatever reason. So some first of them should be quite easy, like only slighter, harder than 2K, and then the last ones are quite difficult. They are around 200, 2,900, something like that, 2,900, 2,800 maybe. And yeah, because there are quite some problems that I missed or did not solve during the contest for whatever reason, as the duration of the contest is 5 hours. So going somewhat of an ICPC style here. Yeah, so that's like some background on why we have this video in the first place. And of course, I think that like some of these problems may actually be interesting, some may be rather dull. I don't know yet. I did not, like for most of them, I didn't even have time to think about them during the contest. So that's it. And also, like I imagine that watching 5-hour long videos is not particularly interesting. Of course, I'll make some timestamps for this one. So yeah, I'll probably cut the recording like when I'm just thinking about problems, and then just record parts. Just record parts when I'm actually doing something. And then, yeah, and maybe then merge this together or whatever. It's more of a technical detail. Let me just quickly open like complete problem set so that you get a feeling of what's about to come. Apparently, connection is not perfect today, but it won't influence our training session significantly. I think that's like something like 4 of my friends registered. Not exactly sure how many of them will actually participate, but this is somewhat a high-rated contest, so it's totally fine if you find these problems a bit too difficult and don't want to solve them just yet. So in problem A, we have A-B graph. Your friend Sam is Warwax browser and all lost math and geometry problems. Yeah, I remember it must be from 699, which I missed, which was a diff 2 rounds. And I think it was something like, well, it's 2K, right? And it's diff 2 rounds. So it should have been at least D. So just to give you a fun of what level of problems is, it's probably diff 2D, and then up to D1, I don't know what, maybe even to D1D as well. But more likely diff 2F, G, E, all these letter problems may be here very well. So we have a graph problem. We're given complete. This word should be in bold. Directed graph with n vertices without self-loops. Yeah. Each edge is labeled with either A or B. Okay, these edges may have different labels. Okay. We're given an integer m greater than 0. We want to find a path of length m such that the string obtained by, the path is a palindrome. The length of the path number of edges. Okay. Okay, we can visit. Right. Looking at the input format, we will definitely need string and vector. And I don't have, yeah, I think this is like a different environment, and maybe I don't have bits here, but whatever is relevant to the solution. I'm also going to try to write everything like quite understandable, and not like in rate chart, because I think it's more important during upsolving to actually like make sure that you do everything clearly, so that you actually maybe learn a new idea in all the details. Plus, I mean, you got tab, right? Tab. You can declare a variable, a vector, vertex count, and then just type VC, press tab, and here it goes. And PL, just like that. So it doesn't really, like, to all people who think that short variable names do a lot of difference, they don't. I would say that before you're like quite comfortable with your code, actually short variable names may hurt you because you just miss one or another detail of your code because of short variable names. And here, like, you're completely confident with what you're doing if you're using one names. We have that many. Well, that's not really in edge labels. I think edge label raw makes more sense. Okay, so here's our inputs. Here we're going to do something. So we have a complete graph. So we're given like this matrix. Really cool drawings in MS Paint here. Absolutely. Let me think. Want the path to be palindrome, and the graph is complete, so we basically can go like anywhere. Well, if the length of the path is even, no, wait, if there are two vertices which have, and because we are not in a hurry, we can very well take our time. Suppose there are two vertices, U and V, which have the same label. Let's say A was here and here, and then answer is yes. Here the answer is yes. Actually, if we have different labels, let's think about this. If A, B, here's V, here's U, and M is odd. And answer is yes as well, just because like we start A, B, A, B, A. It's palindrome. So, and then like the interesting case, I suppose, is when, so let me compress this one. Oops, this one. So, and n is at least 2, so there are paths. No such corner cases for us. So let's see. Do I have to print the path? Yeah, unfortunately. Well, actually, like, what prevents me from doing something like that? I think nothing. Well, apart, apart, apart. Yeah, and another good feature of having a YouTube channel is that you can practice your English because it's obviously far from perfect, far from being perfect. That's in buzzword. Um, so here what we do, we just generate paths, which looks like 1, 2, 1, 2, 1, 2, 1, 2. We always can do this. That's pretty much it. It works for all odd amps, for even amps, for even amps. I mean, like UV are okay names for purposes, more or less understandable. I mean, we are going to use them like several lines. It's okay to have one letter variable names. Well, that's actually incorrect because, yeah, some comments for most of you guys who is not sure what this is doing is checking the pass length is odd. Um, here, well, we can actually go all the way up to U only. Yeah, that was much easier. I did not thought about it. So if we get two letters which are the same, first thing we're going to do is say from equals true so that we stop alternating. Let's simply have to output anything here. But here we do have to alternate between U and V. Well, it's the same, but like here. Okay, we're going to do this, and we're going to print U. Also, we're going to print U. And of course, we add +1 because, so these are these two cases. In the second, like we are left in the case when between each pair of vertices there are two different edges. One way goes A, other way is B, and we want to find a palindrome of even lengths. We want a palindrome of length 2, then we basically want AA or BB. What does it tell us? What does it tell us? Well, actual, like, if vertex counts is 2, I'm pretty sure it's impossible. Oh, I also forgot to print yes. I think we should make like a function for this purpose. Does not have to capture anything actually. I'm going to return anything from here. And then this is here, else. Just because I want to print everything with it. And for here, it would be something like 0, 1. And here it would be print cyclic path from U and V. Here it's just an empty vector. I think we can do something like that. We have ourselves a cycle. Cycle is empty, then we want to print no, otherwise we want to print yes and print cycle. Start from here and then solve here. It makes sense. Else, I'm pretty sure the answer is positive. Let me see. For pass length equal to 2, we want AA. We always can find AA. Is it true? Yeah, if we have those 3 vertices, then of course we can have AA in a row. And if we have 4, we have AA, which means the 3 verse edges are BB. And we can just start at the second one of them. We have 6, and we want to start at the first one. Okay. Yeah, so the idea I'm talking about is like we have 3 vertices which are, I'm going to draw it bigger and then I'm going to just compress it. Have U with W, right? So no matter how you try to rotate, to direct these edges, like let's look at A and A and A. Like some of these edges between each pair of vertices, there is directed edge with A because we are in this case, and we haven't found such situation. Because of this, we also have reverse edges which are B. In particular, what we have here, let me think. We have this. And you can always find a palindromic path inside of here somewhere. These heat boxes are quite hard, I must say. Like, okay, oh, okay. I guess the black part actually arises at whatever. And then based on the half lengths, if half length is even, then you want to start, I think, at the beginning, at U, and if half length is odd, then you want to start at V and go just this sequence. So this can be easily compressed. The arrows are weirdly compressed, I must say. Like the arrow does not get compressed. I think it's not the expected behavior. I'm guessing because it's an object on its own. Yeah, I think it's unavoidable. Insert this. Okay, so now we actually have to find UVW. I have no better idea than doing this. And then I'm gonna make it like this. So I have this rather rarely seen loop. So it's algorithm. Okay, understandable. And we just have a condition to break on, right? Have edge label, then permutation 0, permutation second 1. So I'm thinking that we just break. Or actually we can say well, I want this path to be A and A. I don't care, I just want them to be equal. If they are equal, then I'm happy. It's obviously symmetrical. If half length is odd, I want to start. No, wait. If half length is odd, then I want to start at U. So I'm going to call print cyclic class of U V W V, and I have changed this to permutation. And if it's even, let's say 4, then I want to start in the middle. So I'm going to shift this by 1. And by now we should be fine if this actually compiles, because it may not. Can we have, okay. A means, where is it? Okay. Slants. Yeah. Okay. Well, the answers are G's, I guess. No, wait. Pass slants. I think when I'm printing a loop, I should just print one more. They're from the first 3 test cases shown below. So let's say I go 1, 2, 1, 2. Yeah, that's cool. Yeah, I just use 2. And then I have 1, 3. Okay. Can we construct a graph maybe ourselves? This when we in the last case say A. Yeah, and an easy way to do it is to just four, right? Now let's say, oh, let's actually have like 8 test cases. Oh, this is already covered, so we may stick with, say, passive length 5 and passive length 6. Passive length 5 is 1, 2, 1, 2, and then 1, 2, 3, 2, 1, 2, 3. No, 1, 2, 3, 2, 1, 2, 3, which is completely, which is exactly what we intended to make here. I think we are good to go. So one of the things I wanted to try to improve is to learn how to make more tests, like my own test. maybe everyone is still at work because it's not all that late in the evening so far. So I'm the only person so far to solve, to at least attempt something. It looks okay. Should be okay by now. Okay. Yeah, I mean, it's pretty clear that I'm the only person to submit this time. Yes. Maybe more people will join later, but it's irrelevant to our practice, right? So I'm thinking I kind of can erase this everything. Reserve faster matches, of course. Uh, okay. Okay, I don't want to solve geometry just yet. You know what? I think it's a good time to have a short break in the recording because, yeah, I will try to think about the geometry and then we'll just I will resume the recording when I come up with some ideas of what I want to cut, something like that. I'll just create a file and I'll be back when I know how to solve the problem and I will walk you through because it may not be very interesting, maybe not very interesting to see me like drawing on paper some geometry problems for half an hour. So we'll join back when I'm ready to discuss the solution. So welcome back, guys. It's been like only 5 minutes. Now I'm actually, to be honest, I'm a bit ashamed because this is a problem from D1 contest that I did not solve. And I did not solve it mainly because problem B in that contest was segment tree, and I was a bit afraid of segment trees at that moment. Now that I think about it, like this problem is so trivial, I should have gone for it. But I'm also a bit afraid of geometry, but yeah, so let me show you what I thought so far, which I believe is a complete solution already, but let's see. We have several points and we want to find a permutation of points such that if we connect neighboring points in the permutation by line, consider it like this, all the angles between 3 consecutive points, then all these angles should be acute. So that's strictly less than 90 degrees, right? What I think about it, if the angle is more than 90 degrees, I actually should. Yes, I knew the word, but now I forgot. So obtuse. Let me actually check the timers. Obtuse. Yeah. It's nice way actually to check that your pronunciation is like more or less okay. Obviously, it won't check that you're perfect, but so yeah, if we have an obtuse angle here, which is like ABC, Like the main thing you have to know about obtuse angles and triangles, and overall about triangles, is the greater the angle is the greater is the opposite side. Now, like so. Let me actually draw a triangle. Right. So I have three angles here, not surprisingly. And I will also mark sides like A, B, and C as small letters. And then in our case, A is smaller than C and small. Well, I'm not sure about A and C, probably. Suppose that A is smaller than B and smaller than A is smaller than C, which is smaller than B. It means that angle A is smaller than angle C, which is in turn smaller than angle B. Because you have sine theorem, which states that I think something like that. I think. And here, like because the ratio A to sine, B to sine, C to sine is constant, equal to 2 radius of circumcircle, right? I guess you can say just simply circumradius, and it will mean that the radius of circumcircle. So because this ratio is constant and sine is monotone function from 0 to what? Sure. It clearly is from 0 to pi over 2, right? But what? Then gets decreasing. What? No, well, I'm guessing like it's not because the sine is increasing function from sine is not an increasing function from 0 to pi, but like if you think about like if this is 120 degrees, and sine is the same as 60 degrees, and 60 degrees is a leftover once you get rid of this 120 degrees. So sum of C and A is 60 degrees, and you have B, which is equal to their sum. So its sine, and this angle is from 0 to pi over 2. So its sine is clearly greater than the sine of A and C both of them. So that's why, like, the greater the angle, the greater the opposite side, and vice versa. What this leads us to is that if we ever end up in a situation where ABC is obtuse, it's because we selected point B and selected point C. And at that moment when we selected, point C was like quite far away. And for some reason we selected B. And I noticed this condition, which says like, well, you can actually do build one by one vertex by one in like linear time per vertex. And in this case, it sounds like you can just select the furthest point from wherever you are currently at. You select the furthest point, and you will never end up in a situation like that because your side is the longest one. Triangle. You can never have angle, not even 120 degrees, or maybe. No, okay, it's fair enough. Like, no. I think, like, suppose we gone to B and B was furthest from you, right? What it means is that that currently you can be like the next point can be in this circle, right? Centered at A with radius AB. And then all, yeah, like actually, you can clearly see like no matter where we go next, even if we go super close, this is smaller than 90 degrees. Like, and on average is quite small. Because of this property, you're going to go like in the opposite direction to where you was, to where you came from. Yeah, something like that. Let me actually compress it like a lot. Constraints are very gentle, I think. Like this kind of thing, when you go to the furthest point, it can be solved faster than linear time, but it was not, apparently I'm a fool, and it was not entirely like a hard problem, and I just get scared of it. And the corresponding div one rounds. Uh, let's actually make it nice. I mean, this is Upsolving, we can afford it. We have a point, and we got x and y coordinates, which I believe are integers. Now, there is a tricky part. Like we are about to see why. Like I clearly don't want to suffer from precision issues. With such constraints, I can just easily fit distance. Like I use square distance for sorting. Uh, all right, yeah, this is the input format clearly. Um, yeah, not too many test cases for us, but this solution kind of sounds like pretty easy, so you should not suffer from anything apart from this thing here. I guess we can make it in line. It should not measure like at all, like a lot. Maybe it matters a bit. Let me check something. Yeah, okay. It's getting dark, however, so maybe we'll have a pause after this problem, or maybe after the next problem, and adjust the light setup. Let me see. Let me actually put points in. Okay. The reason for this is because I want to quickly extract points, right? So let's see, points. Not sure if I should. I think I should just. One of the things I happen to notice about myself is that I kind of like it when every part is in its own. So like we read input and then we do whatever we want and we don't do anything while we're reading input. It actually slows me down a bit in the contests. Okay, I could have read everything into a set like initially. But maybe it's better to keep it this way, not to make any stupid errors. We'll see. Oh, actually, if we have ID, an ID is a complete order, right? I want a permutation and variance. I'm going to print it like that. I may as well. No, let's keep it clear. Wait, if I think if I do it like that, then I will be able to erase points just from ID. I also want to be able to construct point. So let's say I do it like this, and then yes, ID, X. I think I should make it like this to avoid any determinants. I can entirely sure. Okay. So now I can construct points from ID immediately. They will understand that this is ID. For some reason ID is long, but yeah, it's all. It's a very evil way to phrase the question, like when there's no solution, I'll put a -1, and then there's always a solution. And we can just select the first point in linear time. Actually, we should have one. I think if you take it like this, then you're fine. So first point gets this. And the last thing I want to do is permutation. ID. Okay, yeah, because it's where exactly? What? Wait. I don't even get the line. Oh, I get 43. Understand. Wait, okay, okay. Yeah, I got it. Yeah, because this sync actually wants something like this. One, two, four, three, five. Well, that's the correct permutation. And it appears to be going to the furthest point indeed, which is exactly what we want. And I think it's secure and does not have like stupid issues with integer overflow. So let's give it a go. Oh yes. Well, that's pretty, yeah. I don't know why. Well, actually, it took me like half an hour still to solve. But I definitely should have switched between C and B in that contest. And I also definitely should have been ready for the segment tree. And now I clearly need to fix my light setup. So I guess another break will be right now. Let me just clear this and go back here and here. And we have a string problem next. So I'll fix the light and come back when I have ideas about strings. So that's it. See you soon. Okay, so welcome back to problem C. Problem C is pattern matching, and I believe it's from some educational round. It was problem E. So basically in that round, I solved ABCD. For some reason, I was quite slow, so I decided not to solve E, but I think it's not all that difficult. Like, it's really confusing, this statement, but I think I understand what they wanted from me. So what we have here, we have some patterns. I should check. Patterns. Well, yeah, it kind of understands what I'm talking about, but clearly it's somewhat called. Oh, never mind, apparently I can't speak. Or maybe it just takes some time to process. So we have I'm sorry, I was practicing that A. So we have n patterns, P1, P2, Pn, and M strings S1, S2, Sm. Each pattern consists of k characters that are either lowercase, Latin letters, or wildcard characters denoted by underscores. So I have like situation when we have patterns and strings and want to rearrange the patterns in such a way that like this string, the first pattern that it matches is going to be the first pattern in input order, and that part is really confusingly ordered. This is never expect people to understand what you mean by permutations, unless it's a permutation problem. It is sort of permutation problem, but I mean, just don't use it if you can, because it's really confusing. I'm pretty sure there are better ways to phrase it. What we're going to need is like, let's look at the patterns. So we have patterns, okay? I'm going to place only their indices in. And each string, it means that, like, say ABCD, right? ABCD wants to match first pattern first. So the other patterns that ABCD matches should come after ABCD. And this includes 5 and 1, I believe. And it does not match 2 and 3. Now, ABBA wants to match second pattern first. ABBA, except from second pattern, also matches the first pattern. So we add such edge. DBCD wants to match fifth pattern first, but it also matches the first pattern I think. DBCD, yeah. So now we get a graph in such way, and because all strings are relatively short, it means the degree of every vertex will be at most 2 to the power of k. So degree is at most 2 to the power of k, which is like 16, which is at most 16. So we are not very worried about that because what we want is topper sort, right? One topper sort. Yeah, and then we can just print vertices in the order of topper sort, or if there is no topological order, and then the answer is just no. So we construct a graph, we find topological order, and if there is none, then we lose. If there is some, then we have to output it. Like non-trivial part consists of realizing that this is a graph problem and not a string problem. So let's see. And what I think I want is a map from pattern to its index. Well, that's not a correct loop because I will need index either way. Then I just take pattern. I say pattern index at pattern. Yes, so that's it for, because I need to quickly get the ID of the vertex by pattern. And I hope that all patterns are distinct. It should be guaranteed because isn't it guaranteed? All patterns pairwise distinct. Good. Strings don't have to be distinct though. So, yeah, it does not match. But strings are, they kind of just encode some edges. So I'm not interested in string ID. And you want index. So let's call it first index, just to be a bit more explicit. But yeah, I want to be sure that there is a match. Now, if no match at string and pattern's first index, just going to output no and return 0. Okay. It's not the best practice to do it like this, but yeah, otherwise, for every beat mask, we increment by this, else pattern gets incremented by string at I. If pattern index count pattern, and this should definitely get decremented by 1. And here we get this thing. Yeah, just to avoid self loops. Then we want tuple sort graph. Which I believe is done with 2DFS algorithm. Sorry, not now, guys. Hmm. Let me think. Like, first thing that I definitely want to do is this. And I'm really sorry, but Okay. This is quite hard to remember. Okay. Usually just use it, right? Yes, I think it's right. So you just have something like order, and you have to push when exiting, right? On exit, right? You just have to push on exit. Of course, you want to have like visitors, button counts, back, vertex, vertex gets true for adjacent graph. Did I can't forget what is the correct spelling. Yeah, okay. Um, that's what's adjacent. And second, yeah, okay. And adjacent. That's simple and that's. And now we want so I think I want index plus one here, which is typically right as the following. Then I simply have to reverse the order because first we will no actually yeah okay, but this does not answer the question like where it does not exist. We should think about this. It does not exist when you went in the vertex. It is still gray. Uh, Actually, there's a better name for failed, which is cycle. Yes. Okay. Okay. 44 is a problem. In Bitmask, absolutely. I saw that I used bitset for a second. 57 is a problem. Function is not here because function is here. Yeah, good. 32451. Well, that's a possible answer. The answer is no, and here the answer is no as well. I think we should give it a try. I must say that we are moving at a slow but steady speed. Okay, so Codeforces actual, like my connection broke, which is broke, but it's okay. I lost maybe like 1 minute or 2. I think it's safe to go back to that link. Yeah. Well, that's a bit on the end because we use an, I believe, map of string to int. But then again, it was like, yeah, it's like one. Let's actually check if an ordered map works. I'm a bit afraid to use an ordered map, but like after you know yourself what happens. Yeah, so there are no anti-hash tests apparently. But map is as well okay because we have just like n log n for map. N log n times k, which is still okay. So I'm guessing still nobody joined because it's like basically still a working time, and I just have I have a specific schedule which allows me to do all these things. Yeah. Next problem is a bit similar, which is actually the first time I watched Neil's stream. He was talking about this problem, and I tried to upsolve it, but I ran into some issues. So I'll take a break to just make sure that everything that my idea works correctly and then come back. Yeah, I clearly will have to do a lot of video merging, but it's okay. So yeah, I'll see you soon. Welcome back, and I think I figured out what was wrong with problem D. So in problem D, we have, well, first of all, we have several test cases. So let's start with this. An actual test case consists of two integers and one string, which are lengths, substring lengths, and string itself. Now, and we want to find like strings are bit strings. Well, I want to find a string of a length, substring length, not surprisingly, yes, so that it's a bit similar to every substring of a given length. Like the idea that I remember from the previous time is that if you have a substring, let's say it looks like this, and you want your string to be a bit similar to this, and the only substring that this substring bands is the inversion, right? And then, so that's the first idea. So you like every substring bands at like one substring, one potential answer. Maybe different substrings band the same answer, then you're lucky. Maybe they don't, and then you're not very lucky. But the point is, like, because they only ban one substring, you have that many possible substrings, and only that many are bands. So you can put these band strings in some set, and just check for small substrings whether they are here or not here. Obviously, for huge values of k, it does not work because long substrings is never a good idea. Many long substrings is not a good idea. But you can put suffixes because this number is so huge. If k is equal to 10,000, you're guaranteed to have an answer. You just want to find it. And the way you find it is you put suffixes of lengths approximately log of this, invert them, put them in some set, and then work with this set. That's what we're gonna do. So I have that many substrings. Now I think I want something like this. Not entirely sure, but it sounds very reasonable. And once I include CMS and string, I will also need set. Actually, band is semantically better name. I'm guessing substring lengths. Surely substring lengths -1 should be the possible option as well. This last position is just too long. Now, what are ones? Basically want to take it and then invert it, right? So what if I just say string substring, and from last minus suffix length, suffix length. I also wanted to find lexicographically minimal string, but it just means that you can set a lot of first bits to 0. I'm sorry if I skipped over this part. Just remember it from the last time. Then what was it's like band suffixes, sort, suffix. Now here's the interesting part: substring length minus suffix length. This is all these zeros that we talked about, this prefix of zeros. And then we take all bit masks. Suffix length is approximately 16, maybe, no, it was 20, but it's still okay. Maybe we'll need an ordered set here, but I hope no. Because I don't really want to think about hash collisions. Is it a problem of both an ordered map and an ordered set and only an ordered map? I have to ask that because I don't know. I don't want to get into the implementation of the set. It's the in ordered set, I'm sorry. Wait, there should be an easy way to check this, right? It's like toString, but then base. What is it? Let me know. There is no base, really? Honestly. Yeah, whatever. If bit mask and bit suffix gets this, suffix gets this. If not, band suffixes count suffix. First of all, found gets true, then answer gets incremented by suffix. If found gets yes, answer other new line. Else, we want to output just no. Apparently, I did not import Elga. Let me check. No, but log 2 should be. Do you want me to cast it like this? Oh, whoa, that's not good. Something went wrong, but I don't know what and why. Now wait. I think I want this loop. One one zero 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 one zero one one zero. Oh, sorry, I just should drink something, you know. Let's check if our set of strings does not TLE actually. Which is quite interesting. Now the policy of this Upsolving is actually that you can't see what test cases you, like the first test case that you got wrong. So Jur's answer is better. Wow. How is it possible actually? Like maybe I banned too many substrings? Yeah, I think this is not a good idea to trade from last. I don't know why I decided to go like this. Suffix lens. Yes, thank you for notifications. Pretty sure that oh, now I remember why I went with last. Maybe it's not always sufficient to take just this, but I'm sort of surprised. This should be completely equivalent. Except for maybe when we take like too many. Let's walk it through. We clearly can't take this. This is like not a problem. It's going to be twice as slow, but well, actually, it's going to be twice as slow. This is not something we can afford. This is not good. So if last equals length, like say length is 10 and substring length is 3, and suffix length is like 2. And the first thing we're going to take is from 8, then 2s, which 8 and 9, which is correct. The last thing that we're going to take is substring length, so from third, we take -2. I don't understand. From third, we subtract 2, and we take first and second. That's exactly what we need. Okay, that's exactly what we need. What is the problem then? Well, I don't know. And their answer is better like by a lot. So I must have missed something. Right, because it's how did it even pass that many tests? Come on. I don't understand. Like, whatever. Keep in mind that STD set may be a bit too slow for this problem, but I hope no. Okay. That's not what I wanted. Their answer is still better, but then just something random? I don't understand. Oh, by the way, somebody tries to solve something. So it differs somewhere in the suffix, right? That actually is the right way to do it. Like, I think I was just, I think it should have fixed it. I think why Juris answer can be better because I banned something that should not be banned. This is one option. If I take more of these, no, then my output will be no, right? If I can't find the answer. So it means that I banned something that I should not ban. Or that I still produce strings in the wrong order. I'm really sure I produce them in the correct order. So like, this is smallest bit. If it's sad, then it's sad. If it's not sad, it's not sad. Then I reverse to make sure that they are actually smallest bits. If I can't find my suffix, good. Stop and add suffix to answer. It's not clear. Another option is that I just simply banned so many suffixes, but it should have like failed before test case 79. But I think I don't. Again, if this is 3 and this is 2, then I start from 1 and I take 2, which corresponds to first and second. It's exactly the first string of length, real length. Also, the equality corresponds to this case, right? Yeah, like first is K. First last is K and then length are the last indices. I invert the suffix and I ban it. When I loop over all small suffixes and check if they are banned, then, well, there is nothing for me here. They're not banned. They are not banned, then I should find the answer at suffix, stop the loop, print the answer. For some reason, the jury has a better answer, which differs only in the suffix. So it means that I banned some suffix that should not be banned, or I'm iterating over suffixes in the wrong order. My order is as follows. I take all bits from zeros to suffix, from least significant to most significant. I add them to suffix. Well, I add them in the wrong order, so I reverse the suffix and I search for suffix. And I don't understand. And man, it's like the third time I'm writing the solution for this problem, and it's still like something breaks. I don't understand. Is there the test data is so good, or is just so, or am I just so bad at this? Something is just completely wrong. I have no idea what is. And technically, this should be substring count. No. Yes, substring count plus 1, because I want to have at least that many. But then it does not really matter. I don't understand. It should not matter. No, I should test maybe something better, but I just don't understand what's wrong. Keep in mind that we may still have to optimize sets on other sets. Yeah. I didn't really help. You don't understand what I'm doing wrong. Understand. Like the result stays the same. Their answer is better than mine, but I still produce an answer, which means that I took enough into suffix length. Then I just have something else banned that I should not have banned. I didn't understand. How is that possible? Like I subtract this minus one from this. You get like I take exactly as many substrings as I should. It's like length minus substring length plus one. For each of them, I take from here to like that many positions. What the hell is wrong? Why? Does that understand? From lowest bit to highest bit. Bit is sad, then it's sad. If it's not sad, then it's not sad. And that way, because we start from lowest to highest, we have to reverse it. If it's not banned, then we found the answer, we add suffix, and we print the result. What can go wrong? Nah, it's not because of this, clearly. Glitch, I don't understand. I read it 3 times. Literally nothing can go wrong. Like nothing. And still something does. Now I don't even know what. It's moments like this when you don't really understand what's going on. It's not fun, I must say. It's completely not fun. That many substrings, it's untaught, and they even say this in the problem statement. Clark, well, this doesn't really matter. Because if this mattered, then we would just say no if it was not enough. Create a set of band suffixes. We take the same number. We ban all these suffixes. We invert our suffix, I must say. Our inverted suffix is banned. Wait. Wait. What if our string actually already differs from that string because the prefixes are not all 0? And you don't have to ban this suffix, right? Oof. That's hard. So by taking a suffix too small, we may ban something extra. It would not be banned otherwise. This is why taking suffix lines may be important. I don't understand. Taking it like 2 times should definitely I think it will result in sealing. We'll optimize it then, if it does. Okay, I don't understand. Is it so annoying problem? I don't understand. Like what? What is like educational value? If this is from educational context, what is the educational value of situation when your code fails test case, which you don't even understand because you can't read it? And their answer is still better than mine. Like that. Honestly, what is this? What should I do? Like, you don't understand if I make it this, just won't pass the sample. I'm pretty sure. Here you see it does not pass the sample. So ban this suffix is important. We have to ban everything that's here. Oh, okay. Apparently, we need some check this separately. Like the situation when prefix is not all zeros. Then has like no. You're only interested in this substring if this difference is equal to this difference. If everything that can, if prefix is all zeros, and then only then we are interested in this. Ah, it does not work. Great. Well, actually, yeah, that's my, no. Like, still doesn't work. Well, okay, this is the first position that we do take. And what is the first position of the string? Is it this? Then last should not get as well as subs. No, 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 no. Like if last is equal to substring line, then this is 0. Should work. Should work. We're checking if the prefix is all zeros or not. Why? Why am I so stupid? Still does not work. not why, okay. This is prefix length. It's all zeros. Then we add band. Wait. No, 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 no. We want to count once. Because ones correspond to inverted zeros. Man, that's so hard. I don't even know it works. That's too hard. Now it should yield, right? Great. Great. Classical tuning. Only barely passed some of the test cases, so it might be pretty close. Yeah, okay, let's see. How about that? Should be faster, right? If no anti-hash tests. Only barely. Maybe because substrings are quite small. I'm not sure why. We can actually reduce it to like a vector of integers. Because we know that each suffix is actually an integer. What if we do just this? Once, right? So band suffixes. Non-band suffixes and suffix. What if I say this? So it gets rewritten like this. No. No. You're an alien. No, no, okay. This is exactly what is going to be set. So if it's set, then suffix should get set bit here as well. Now this part, we have some substring. Here we get something like this. If bit is equal to 0, then suffix. Oh, if bit is equal to 0, then band suffix should add 1 to it. Let's not expect it. Yeah, because we don't want to add suffix, we're going to add basically this loop. think this is what was here previous time. Let's see how much of a speed up is this. Maybe I broke something. Really, I did not. What is this? Oh, okay, so these two are messed up. Right, because here you obviously want some. Is this correct now? Yeah, okay. So, let's check if this works. Okay, this is much better. So it's like, yeah, an ordered set of strings, like physical strings are slow. If you can work with integers and better work with integers, we can clearly see that was memory and time are 10 times slower. No? This I all clearly should have thought it through. Sorry about that. Yeah, well, I mean, all problems are quite hard. So maybe it's okay. And the rest of the boys must be still busy, maybe getting home. Boss boys and girls. I have a problem. Wait, strange shuffle is the problem where we had some difficulties already as well. It's an interactive one. The one about square roots. So I was already solving busted. Yeah, but then I mean I was solving a bit similar as well before, but and it still takes me 1 hour and 12 minutes to solve it. So it's not all that easy. So yeah. I think I'm going to take another break. Yeah, I know, yet another break. But then, I mean, like, each of these problems is quite hard if you don't train like this on a daily basis. I hope we'll get like to F. I don't know about G, but F will be like halfway through. So kind of came. Maybe I'll just upsolve the rest like in another separate session. Which won't be tomorrow, because tomorrow we have a contest, a div2 contest based on some Moscow competition. So, yeah, actually, I should register for that. And kind of coincides with my university schedule, but I think it's fine if I ask teachers about like I'm going to go to a programming contest. I think they will be quite loyal. At least in our country, they usually are. So that's it for this problem. I will come back when I'm ready to discuss that. I already have some ideas. I just need to like make it all work, clearly work.